This is SpaceTime, Series 22, Episode 58. Coming up on SpaceTime, the birth of our Milky Way galaxy, LightSail 2 successfully demonstrates solar cell spaceflight, and the best-known meteor shower of the year, the Perseids, are back. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The barred spiral galaxy, which we call the Milky Way, was formed out of the collision of two major galaxies about 10 billion years ago. They're the key findings in a report in the journal Nature Astronomy, developed by astronomers from the Institute of Astrophysics in the Canary Islands, using data from the European Space Agency's Gaia Space Telescope. The universe is some 13.8 billion years old. And up to about 13 billion years ago, it was a very different cosmos to what we see today. Back then, stars were forming at a prodigious rate. The first chaotic dwarf galaxies were appearing, and it was the mergers of these which gave rise to the more massive galaxies we see around us today, and that includes our own galaxy, the Milky Way. However, the exact chain of events which produced the Milky Way galaxy hasn't really been known till now. To remedy that, astronomers used data from the Gaia Space Telescope to take exact measurements of positions, brightnesses and distances of around 1 million stars in our galaxy within 6,500 light-years of the Sun. The measurements, when combined, have provided an interesting picture of the Milky Way's early stages. The authors analysed and compared the Gaia observations to theoretical models, looking at the distribution of colours and magnitudes, that is brightnesses, of stars in the Milky Way. They split them into several components: the so-called stellar halo, a spherical structure which surrounds the spiral galaxies, and the thick disk, that is the stars forming the disk of our galaxy, but occupying only up to a certain height range. Previous studies had already discovered that the galactic halo showed clear signs of being made up of two distinct components, one dominated by bluer stars than the other. The movement of the stars in this bluer component allowed the authors to identify it as the remains of another galaxy, a dwarf galaxy which they've called Gaia Enceladus, which must have impacted into the early Milky Way. However, the nature of the red population and the epoch of the merger itself between Gaia Enceladus and the primary galaxy were unknown, at least until now. Analysing the data from Gaia has allowed the authors to obtain the distribution of ages of stars in both components, and this has shown that the two are formed by equally old stars, which are older than those in the thick disk. But if both components were formed at the same time, what is it that differentiates one from the other? The final piece of the puzzle was obtained by looking at the composition of the stars, looking at the metals they contained. Metals are what astronomers call all the other elements on the periodic table other than hydrogen and helium, the primary elements formed in the Big Bang itself. Stars in the bluer component were found to have lower metallicity, that is, a smaller quantity of metals, than those in the red component. These findings, together with the addition of the predictions of simulations, have allowed the researchers to complete the history of the formation of the Milky Way. They found that 13 billion years ago, stars began to form two very different stellar systems, which then merged. One was the dwarf galaxy Gaia Enceladus, and the other was the main progenitor to the Milky Way, some 4 times more massive and with a larger proportion of metals. Then about 10 billion years ago, there was a violent collision between the more massive progenitor system and Gaia Enceladus. As a result, some of its stars and those of Gaia Enceladus were sent into chaotic motion, eventually forming the halo around the present-day Milky Way. After that, there were violent bursts of star formation until about 6 billion years ago, when the gas settled into the disk of the galaxy and produced what astronomers today call the thin disk. Until now, all of the cosmological predictions and the observations of distant spiral galaxies similar to the Milky Way had hinted that this violent phase of merging between smaller structures was quite frequent. But this new study has been able to identify the specific details of this process in our own galaxy, revealing the first stages of our cosmic history in unprecedented detail. I'm Stuart Gary. You're listening to SpaceTime. Well, after years of computer simulations and countless ground tests, the Planetary Society's crowdfunded LightSail 2 spacecraft has successfully demonstrated spaceflight by light, raising its orbit solely on the power of sunlight. Since unfurling the spacecraft's silver aluminized Mylar solar sail last week, mission managers have been optimizing the way the spacecraft orients itself during solar sailing. And after a few tweaks, the LightSail 2 CubeSat began raising its orbital apogee, that is its highest altitudinal position around the Earth, by around 2 kilometers over 4 days. The maneuver also lowered its perigee or lowest orbital altitude by about the same amount. Mission managers say that's consistent with pre-flight expectations for the effects of atmospheric drag on the spacecraft. Planetary Society Chief Scientist Bruce Perseids says it's the first time a small CubeSat has demonstrated controlled solar sailing, that is, changing the spacecraft's orbit using only light pressure from the Sun. The only other spacecraft to have achieved this was Japan's Icarus. Developed by the Japan Aerospace Exploration Agency JAXA, the interplanetary kite craft accelerated by radiation of the Sun, or Icarus, was launched in May 2010 aboard an H-2A rocket, together with the Akasui Venus Climate Orbiter and 4 smaller spacecraft. Icarus was the first spacecraft to successfully demonstrate solar sailing technology in interplanetary space, using only gravity and the pressure of photons to travel to Venus in 8 months. LightSail 2 mission managers will continue raising LightSail 2's orbit for roughly a month, until the perigee decreases to the point where atmospheric drag overcomes the thrust from solar sailing. During the orbit-raising period, the team will continue optimizing the spacecraft's performance. After LightSail 2's month-long orbit-raising phase, the spacecraft will begin to deorbit, eventually re-entering the atmosphere in roughly a year. Now, in case you're interested, the silver solar sail is about the size of a boxing ring, and it can be seen quite clearly from the ground at dusk and dawn when the light's just right. The LightSail program began back in 2009 under the direction of Planetary Society co-founder Louis Friedman. It followed the launch of Cosmos 1, the world's first solar sail spacecraft, which unfortunately failed to reach orbit. Friedman, together with Society co-founders Carl Sagan and Bruce Murray, championed the idea of solar sailing more than 4 decades ago with a proposed solar sail mission to Halley's Comet. To find out more about LightSail 2, Andrew Dunkley is speaking with astronomer Dr. Fred Watson.
Now, Fred, a lot of people are looking at different ways of delivering payloads and people into space, returnable combustion launches and all sorts of things. But right now, as we speak, there is a test going on near the planet where they're using a solar sail. This is a fuel-less process to push something along across interstellar space, technically. Tell us what they're doing.
Yes, that's right. So it's a bit of a hot topic in the science of astrodynamics, how you send spacecraft around. The idea of a very large sheet of very fine material, something like Mylar, which will catch the photons of light that come from a bright source, and in this case it's the sun, which is why we call it a solar sail. And those photons of light actually, they impart momentum to the solar sail. And because that solar sail is big, the momentum that you gain from the sun is significant, and it actually pushes the spacecraft forward or in a direction away from the light source. So this is something that's been an idea that's been around for a long time. It is, just as an aside, it's one of the proposals that will be tested in a program called Breakthrough Starshot, which is an idea supported by the Breakthrough Initiatives Foundation. I think that's what it's called, initiated by a Russian billionaire by the name of Yuri Milner. He's set up a number of initiatives which are called Breakthrough generically. One of them is Breakthrough Listen, that involves kind of SETI-type observations with 2 very large radio telescopes, one of which is here in Australia, the other in the United States. But Breakthrough Starshot is looking at the potential of a laser-driven solar sail flight to the nearest star other than the Sun, Proxima Centauri. That work is ongoing. Meanwhile, the work that we're talking about today is unfolding, and that's probably the best word for it, before our eyes, because the Planetary Society, which is a non-profit organisation, very well-established, long-established society with its mission to explore the planets, they crowdfunded a little spacecraft called LightSail 2, which was launched in June, about a month ago, June 25th. And then a few days ago, it actually opened its light sail successfully and is now kind of sailing. I think it's basically at the moment, it's drifting in an orbit about a bit more than 700 kilometers above the Earth's surface. And as we speak, what the mission scientists are doing with LightSail 2 is using the solar sail to change its orbit. And that's the kind of critical test. If you can set up the solar sail in such a way that it's receiving light from the sun in a particular direction, and then see the effect of that acceleration on the orbit of the spacecraft, then you know that things are working properly and you're kind of on a winner. What's also a winner, I think, is some lovely photographs that were sent back pretty well as soon as LightSail 2 was deployed, showing the spacecraft with the Earth in the background. Very, very nice imagery.
A spectacular photo. It's like somebody threw away a picnic blanket and they just caught it while it was spiralling up through the air.
Oh, that's right. A very shiny picnic blanket.
A very shiny one. Yeah.
Yeah. Go ahead, Andrew.
I was just going to ask, how do you steer?
Yeah, so you've got to be able to change the angle of the sail in relation to the...
So it's not unlike sailing in the wind?
Exactly the same, with a few subtleties, of course.
So you need to learn to tack and you lead and whatever else.
I'm not sure about tacking, sailing to windward or solar windward. It's really all about, you think more in terms of the laws of reflection as to how this would work out. You want the solar sail to be in an angle to the sun, which gives you the acceleration in the direction you want it to be. Because what you really don't want to do is inadvertently slow it down rather than speed it up.
Yeah. And the other thing that came to mind was, how fast can you go?
Well, the Breakthrough Starshot program, using not solar power but laser power, they're very high powered lasers, which are one of the things that they're actually researching, whether you can ever make these things. So you have these things on Earth and you shoot them, the laser beams, at your solar sail and just blast it along, and you do it for a relatively short length of time but with a very large amount of energy. So you kind of need a whole city power station to provide the power to the laser.
But once it's going, it's going.
Yeah, that's right. But they're talking about speeds of about a third of the speed of light.
Wow.
So you're talking about 100,000 kilometers per second. Mind you, their spacecraft that they're talking about weigh a fraction of a gram. They're just like a chip with a few electronics on it. They will be beam the signals back. This is all still very much in the world of speculation, but it's what the Breakthrough Starshot program is working on. And it's quite nice that the Planetary Society are sort of coming to the party on this and doing some tests to actually check out whether these fairly esoteric ideas will work.
Yeah, it is exciting news. And if they can find I suppose a comparatively cheap form of functional propulsion, there could be some very good applications for it, especially for unmanned long-haul travel, I suppose.
That's right. It is. It's basically, as you say, it's long-haul travel. And it's probably, well, the whole idea of Breakthrough Starshot is to try and get a probe to Proxima Centauri in something less than a human lifetime, because if you do it with chemical rockets, your travel time is about 60,000 years, and most people lose interest on that sort of time.
I would get a bit bored. I mean, I'd probably be able to solve a Rubik's Cube by then, and that's about it. Without the book.
I could only do it with the book.
That's Professor Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. Time now to turn our eyes to the skies and check out the celestial sphere for August on Skywatch. August is the 8th month of the year in the Julian and Gregorian calendars. It was originally named Sextilis in Latin because it was the 6th month of the original 10-month Roman calendar under Romulus in 753 BCE, back when the year started in March. It only became the 8th month when January and February were added. In the year 8 BCE, it was renamed in honour of the Roman statesman and military leader Augustus, who had achieved several of his great triumphs, including the conquest of Egypt, during the month. The constellation Scorpius the Scorpion is high overhead this time of the year, covering almost a third of the August night skies. And marking the heart of the Scorpion is the red supergiant Antares. Located some 470 light-years away, Antares means rival of Mars, and when they're close together in the sky they do look very similar. A light-year is about 10 trillion kilometres. It's the distance a photon can travel in a year in a vacuum at 300,000 kilometres per second, which is the speed of light and the ultimate speed limit of the universe. Antares, also known as Alpha Scorpii, has some 12.4 times the mass and 450 times the diameter of the Sun, making it one of the largest known stars in the universe. Located near Antares is the globular cluster Messier 4, or M4 for short. Named after the 18th century French astronomer and comet hunter Charles Messier, it's one of a catalogue of 103 fuzzy objects which were not comets, which Messier listed so he didn't waste his time looking for them. Other astronomers have since added further celestial objects to the catalogue, bringing the total now to 110. Located about 7,000 light-years away, M4 can be seen through a pair of binoculars, making it one of the closest globular clusters to Earth. Globular clusters are densely packed spheres containing thousands, maybe even millions of gravitationally bound stars, which were all originally born at the same time in the same stellar nursery. Globular clusters are usually incredibly ancient, some as old as galaxies dating back around 12 billion years. Located just below the sting of Scorpius are the open star clusters M7 and M6. The nearer of the pair, M7, is about 800 light-years away, while M6 is a more distant 2,000 light-years. Open star clusters are less densely packed than their globular cluster counterparts, with the stars inside them less gravitationally bound and more prone to drift away over time. Another open star cluster in Scorpius is NGC 6231, located about 6,500 light-years away, just near the star Zeta Scorpii. NGC 6231 is a bright open star cluster. It contains about 120 stars, including a significant population of very high luminosity supergiants, as well as numerous white-yellow stars and at least 2 Wolf-Rayet stars. Wolf-Rayets are extremely hot luminous evolved stars nearing the end of their lives. Having run out of hydrogen for core fusion, Wolf-Rayets, or Wolf-Rayets depending on your preferred pronunciation, are stars which are no longer on the main sequence and are now fusing progressively heavier and heavier elements in their cores. In the process, they generate hot, powerful stellar winds, and they have extremely high surface temperatures, up to 200,000 degrees, compared to the Sun's surface temperature of 5,800 degrees Celsius. Just behind Scorpius, we find the constellation Sagittarius, a half-man, half-horse of Greek mythology. Sagittarius can be traced back beyond the Greeks to the ancient Mesopotamian archer god Nergal. Now, as we mentioned in last month's Skywatch, the centre of the Milky Way galaxy is found in Sagittarius, some 27,000 light-years away. For astronomers, Sagittarius is well known for its many nebulae and clusters, more than any other constellation. One of the largest and brightest is the globular cluster M22, big enough to be visible to the unaided eye. Located about 10,600 light-years away, near the galactic bulge, M22 is more elliptical than most globular clusters. It's located just south of the ecliptic, that's the plane in the sky upon which the planets orbit the Sun. It contains more than 70,000 stars, covering an area of about 100 light-years. It also contains 2 black holes, and is one of just a handful of globular clusters known to contain planetary nebulae, the puffed-off outer gaseous envelopes of dead Sun-like stars. Located in the sky next to Scorpius in the west and Sagittarius in the east is the constellation of Ophiuchus, the serpent-bearer, often portrayed as a snake coiled around a man. In Greek mythology, it's Ophiuchus who raises Orion from the dead after he's been stung by Scorpius the scorpion. Ophiuchus contains several star clusters as well as other interesting features, including Barnard's star. Barnard's star is really special because it's the second nearest star system to the Sun, beaten only by the Alpha Centauri triple star system. Located just 5.9 light-years away, Barnard's star is a spectral type M red dwarf. It's tiny, just 0.144 times the mass of the Sun. And compared to our Sun, it's ancient, between 7 and 12 billion years old. That's considerably older than the Sun, which is 4.6 billion years of age. It also makes Barnard's star one of the oldest known stars in the Milky Way galaxy. But that's the thing about red dwarfs. Being so small, they burn through their nuclear fuel supplies really slowly. In fact, in the 13.8 billion year history of our universe, no known red dwarf has ever died of old age. Still, Barnard's star has lost a great deal of its rotational energy. Periodic slight changes in its brightness indicate it rotates about once every 130 Earth days. Now, given its age, Barnard's star was long assumed to be quiescent in terms of stellar activity. But then in 1998, astronomers observed an intense stellar flare, indicating it's a flare star. Flare stars are variable stars which undergo unpredictable dramatic increases in brightness lasting a few minutes. It's believed that the flares on flare stars are analogous to solar flares on the Sun, in that they're generated by stellar magnetic energy stored in the star's atmosphere. If you look to the west of Scorpius, you'll see the constellation Libra, the scales. In Greek mythology, Libra represents the claws of Scorpius. However, the Romans considered Libra distinct from Scorpius and thought them to be scales, symbolizing the equinoxes, the times of the year in March and September when Earth gets equal periods of day and night. In fact, 2,000 years ago, the Sun moved into Libra at the time of the September equinox. But due to a process called precession, as Earth's spin axle wobbles in direction, this point's now been moved into the adjoining constellation of Virgo. Okay, let's turn to the south now, the Southern Cross, and there you'll see the constellation Centaurus, another half-man, half-horse mythical beast. Centaurus was a teacher to many of the Greek gods and heroes. He was placed among the stars of the heavens after accidentally being killed by a poisoned arrow fired by Hercules. Close to the pointer star Beta Centauri, that's the nearer of the two pointers to the Southern Cross, you'll find NGC 5139 Omega Centauri, the largest and brightest globular cluster in the visible sky. Because of its brightness, the ancient Greek mathematician and astronomer Claudius Ptolemy originally thought Omega Centauri was a star. This massive stellar ball has a diameter of more than 150 light-years and contains an estimated 10 million stars, giving it some 4 million times the mass of our Sun. Located some 15,800 light-years away, Omega Centauri is another very ancient globular cluster, thought to be at least 12 billion years old. And it contains many population 2 stars. Now, these were the second generation of stars to have formed, and they were created directly out of the remains of the very first stars to shine. The stars in the core of Omega Centauri are so crowded that they're estimated to average only 1/10 of a light-year away from each other. Now, by comparison, the nearest star to the Sun, Proxima Centauri, is some 4.2 light-years distant. Close to Omega Centauri is the giant lenticular galaxy NGC 5128 Centaurus A. It's a spectacular galaxy when seen through a telescope, looking like it's split in half by a thick band of dust. The galaxy was discovered back in 1826 by astronomer James Dunlop from his home in what is now the Sydney suburb of Parramatta, a long time before the bright lights of a modern city would make such a discovery impossible. Located some 30 million light-years away, Centaurus A is one of the strongest radio sources in the sky, and it's thought to be the result of a merger between an elliptical and a spiral galaxy. Now, while it can be seen through binoculars, you'll really need a decent telescope to make out its spectacular dust lanes. August is also the time of the peak of the annual Perseids meteor shower. The meteors are the debris trail left behind by the comet Swift-Tuttle as it travels along its 133-year orbit through the solar system. Now, as the name suggests, the Perseids radiant, the point in the sky from which the meteors appear to radiate, is in the constellation Perseus. The Perseids are one of the oldest known meteor showers, with early Chinese historical records of their activity going back almost 2,000 years. They're active between July the 17th and August the 24th, with their peak usually around August the 12th or 13th, at which time you may be lucky enough to see up to 60 meteors an hour. The Perseids are also very bright and fast-moving meteors, travelling at speeds of 59 kilometres per second. They're usually best seen between midnight and just before dawn, producing long, bright trails and some fireballs. Most Perseids will burn up in the atmosphere at altitudes of over 80 kilometres. They're usually best seen from the northern hemisphere, so for southern hemisphere sky watchers, look to the north with the radiant below the northern horizon. And now with the rest of the August night skies, here's Jonathan Nally, editor of Australian Sky and Telescope magazine.
Still winter here in Australasia, so that means our skies are dominated by the Milky Way, which is Sagittarius, which is where is the direction in which the centre of our galaxy lies, is really nice and high. In fact, it's virtually overhead for anyone roughly around the latitude of Sydney, even down towards Melbourne. It's overhead or near enough to overhead to not make any difference. And actually, one of the reasons why there are so many telescopes and observatories down the southern hemisphere have been for a long while is because we have this great view of the Milky Way, the galaxy, from the inside, of course, and the centre of the galaxy, Sagittarius, because it's a area of great focus for astronomers. Lots of dense star fields, lots of sort of interesting objects, astronomical objects in that direction, because we're looking into the sort of the densest part of our galaxy. So there's obviously going to be a lot more there to see than if you're looking in the opposite direction out towards the edge of our galaxy, where there are fewer and fewer things, where the stars sort of get thinner and thinner.
And they're so spectacular too, aren't they? The Trifid Nebula, the Magoo Nebula, and of course, if you could, Sagittarius A star would be there as well.
Sagittarius A star, yeah, right there in the middle of the galaxy. That's where the black hole is.
Which hopefully we'll be able to get to see soon when...
when the Event Horizon Telescope, they're adjusting it or changing it so that it'll be able to see perhaps the black hole in the centre of our galaxy. The thing with that particular telescope and those sort of black holes is it needs to see a big black hole. That's why they chose the particular one they did to be able to get a good view of it. The one in the middle of our galaxy is much smaller than the one that they made that amazing picture of. So it's going to be a bit harder for them to get a picture of the one in the middle of our galaxy. But
it's not very active. Ours is a very quiet black hole in comparison. It's not eating a lot. It's on a diet, one might say.
Well, our whole galaxy is very quiet, sort of old galaxy. There are some galaxies out there, they call them active galaxies. They've got all sorts of things going on. Yeah, and black holes gobbling up stuff and shooting out huge jets of energy through the galaxy, enormous jets of energy and matter. But our galaxy is sort of middle-aged, I guess. It's nice and quiet.
Which is interesting because it is chewing up other galaxies. There are at least 3 that are being gobbled up right now. There's the Sagittarius dwarf on the other side of the Milky Way, and where we are, we've got the Large and Small Magellanic Clouds. They're having stars stolen off them by the Milky Way all the time. But it's happening so slowly. It's not like some of those distant, spectacular galaxies you see where there are massive, violent collisions taking place, lots of new starbursts, and they're really spectacular, bright things to look at.
If you're in the southern hemisphere and you get away from the city lights and you get out to some dark skies, your eyes get dark adapted, and you just look up and you see the Milky Way. I mean, this is the sort of thing you just don't see in the city at all. You just don't see it anymore. It's terrible. Generations of people grow up never seeing the Milky Way if they don't get out to the countryside and get some dark skies. Anyhow, that aside, what else can we see in the night sky in August? Well, down in the south, of course, we've got the Southern Cross, as always. It's in the southwest, lying on its right-hand side, about halfway up from the horizon during the middle part of the evening. The cross, located within the band of the Milky Way. And so if you go from the Southern Cross and you go northwards through the Milky Way, along the line of the Milky Way, there are all these other famous and interesting constellations. We mentioned Sagittarius, but there's Centaurus, there's Scorpius, and one called Scutum. It's right next to Sagittarius, and it does contain some nice deep sky objects. And the constellation is actually named, believe it or not, after an Italian scooter. But not the kind with 2 wheels. That
I was going to say, you're not thinking of Vespa, right?
No, not. You don't wear sunglasses and you drive around Napoli or whatever. No, it's named after a scooter, S-C-U-T-A, which is a kind of ancient Roman shield. If you imagine a flat shield sort of bent so it's like a half a pipe. If you get a pipe and split it down the middle.
I know those ones. Yes.
It's sort of like a rectangle.
I was very young at the time, you understand, but I do remember them.
Ancient Rome, exactly, yeah. So that's what it's named after, Scutum, the shield. Now, if you're out there stargazing for long enough, as the night goes on and the Earth turns, you'll notice something quite interesting, and that is from our vantage point within the galaxy, that band of the Milky Way I've been talking about, which you can see nice and clearly stretching from the northeast down to the southwest across the sky during the middle part of the evening. Well, as the Earth turns, you'll see that the Milky Way gets lower and lower and lower down towards the horizon. That's just because our point of view is changing as the Earth turns. And when you get into the early hours of the morning at this time of the year, you'll find that the Milky Way seems to have disappeared, not up there in the sky. Well, it is still there. It's just that it's all the way around the horizon. The Milky Way that we're in the middle of is just all the way around the horizon. Now, to try and picture that, imagine you've got a hula hoop, right? Now, stay with me. Imagine you've got a hula hoop, right? And you're holding it above your head, and you bring it down sort of so it's in line with your head and tilt it up at 45-degree angle. So then if you look up, you can see half of the hula hoop sort of stretching and going across your head and down the other side. Now, if you bring that hula hoop down so it's horizontal, and your head's right in the middle of the circle, and that means you can look all the way around horizontally, and the hula hoop is all the way around you. Well, that's the view we get from inside our galaxy at this time of the year, in the early morning hours. We're seeing the galaxy from the inside all the way around, and it's really quite an amazing thing when you think about it, if you can sort of imagine all the trees.
Yeah, people think the plane of the solar system is on the same plane as the plane of the Milky Way galaxy as it rotates around Sagittarius A star. That's not the case. The Milky Way is actually tilted at an angle to that.
That's right. Well, you could say the Milky Way is tilted, or our solar system.
The solar system is tilted, yes.
Yeah, whichever one you want. And that's why we don't see the same things all the time, because things are not at the same angle. If everything lined up at the same angle, we just sort of see the same stuff all the time. But because everything's just sort of jumbled up at random angles, that's good. It means we see different things in different seasons. But you're exactly right. It's because these things are tilted at different angles that we see that sort of effect. So anyway, that's the Milky Way. So as I say, in the early morning hours, it's all the way around the horizon, and as you get closer towards sunrise, you see the Milky Ways coming up again above the horizon as the Earth is turning. Now, as for planets this month, there are only really three to mention, as Venus and Mars, which are usually visible at some time or another, they both happen to be around the other side of the Sun, as seen from the Earth at the moment, and therefore we can't see them obviously because of the sun's glare. So they'll be back later in the year in a couple of months' time. If you're an early riser, Mercury's the planet to watch for, rising just above the eastern horizon about an hour before sunrise, but not very high, and only for about the first 2 weeks of this month. Now, after that, it'll be dropping down towards the horizon again and getting lost in the glare of the sun. Jupiter and Saturn are the two ones to watch at the moment, and they're both visible in the evening sky. Jupiter's up nice and high, really, really high, for people down in sort of Australia, New Zealand, those sort of latitudes. It's virtually overhead, in fact, for anyone who lives roughly at the same latitude as Sydney. You go out there in the evening time after it's got dark, and you look straight up, and there's a big, bright thing, looks like a star. Well, that's actually Jupiter. If you take a look on the 9th and the 10th, actually, you'll see the moon very close to the planet. On the 9th, it'll be on one side of the planet, and on the 10th, the moon will have moved a bit in its orbit, and it'll be on the other side of the planet then. This is obviously just line of sight effect because the moon's much closer than Jupiter is. But that's a good way to try and find or identify planets, because the moon, as it goes in its orbit around the Earth, it does sort of tend to pass by each of the planets in the background as it goes along. So 9th and the 10th, go out and have a look. You'll see the moon on one side or the other side of Jupiter. Now, something even more special is going to happen on the 12th, okay, because the moon's going to sidle right up to Saturn, and for those observing from the right locations, it'll actually move in front of it. The moon's actually going to move in front of Saturn and cover it up. Astronomers call this an occultation. To occult means to make something go dark. Okay, that's where we get the occult from, the dark arts, that kind of thing. And even lighthouses. Some lighthouses, you see a flashing light from a distance. That's because it's got a stationary lamp and a sort of a shield that rotates around it with a hole in it. And when the hole comes around, you see the light shining through. At the rest of the time, that light is occulted. So occultation means to make something go dark. So if you're in the right spot on the evening of the 12th, you'll see the moon and Saturn get closer and closer and closer together as the moon's moving along, and then Saturn will just wink out as the moon moves in front of it. Really quite amazing to see. 1 second it's there, next second it's gone. Then, a short while later, Saturn will reappear on the other side of the moon as the moon has trundled along in its orbit. This is also a good way to demonstrate to yourself that the moon is actually moving. Irrespective of the Earth turning, the moon is actually moving as well. It's really something to see, so hopefully you might have some clear skies. Now, not everyone's going to see it. Depends where you are located on the planet. So if you want to know more about that, check out the August edition of Australian Sky Telescope, because we've got all the details there about which location you have to be in to either see the moon occulting Saturn or just getting very, very close to it.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.